Hello. Hey everybody, welcome to Mcool123 Tutor episode 1. Today we're going to talk about the properties of real numbers. So, let's just hop right into it. We'll do some practice and then you'll have a worksheet that you can complete after this video and submit it to me and it'll be good. So, commutative property of addition. What that is just the commutative property in general explains that if you have the same two numbers, it doesn't matter if you flip it or whatever it is. As long as they're the two same numbers on each side, it will still be the same answer. As you see here, A plus B, those are the two numbers. And on the other side, there's B plus A. Even though it's B plus A, there's still A and B, and it doesn't matter the order. So that's why that is the commutative property of addition. Then the commutative property of multiplication, the order of multiplying does not change the product. That means A and B, A times B would be the same as B times A, because it's the same thing. As long as you have those two numbers, they can be flipped, and it would still be the same. Onto the associative property of addition. That means that the grouping numbers differently in parentheses will not change the sum. For example, A plus B plus C, A and B are in parentheses, but in A plus C, B and C are in parentheses. But that doesn't matter because 1 plus 3 is 4. You do whatever in parentheses first. Then plus 5, you get 9. And then here you have 3 plus 5 is 8. 1 plus 8 is 9. So wherever the parentheses are, that it won't matter. It would still work. We could try it on another one. Here, let me go pull up a whiteboard and we'll try it. All right, so here's the whiteboard. So the associative property, A plus B plus C. So let's just give an example. We have, say, 8 plus, say, 7 minus 5. So we have that on that side, and then we have it on this side. So let's say you have your parentheses 8 plus 7, and then you have it 7 minus 5. That would still work. Watch. 8 plus 7 gets you 15. So 15 minus 5 gets you to 10, right? And then 7 minus 5 gets you to 2. 8 plus 2. Sorry, this is bad writing. I'm writing on my computer using a mouse, so it's not very good. I apologize. But 8 plus 2 then equals 10. And then you got that. And that checks correctly. So that's how that associative property works. And that's the same for multiplication. 2 times 4 in this problem is 8, times 6 is 48. 4 times 6 is 24, times 2 is 48. And then we have the additive identity. So, when doing the identity property, remember, it will always keep its identity, and it'll always stay the same. The original number will not change. So, for example, 5 plus what keeps it the same? 0. So basically also 0 in the middle. If you see a problem, you have one number plus 0 equals that same first number. That's the identity property. So you have 3 apples here. That's the original number, but you don't add anything, so it keeps its identity, and you still have 3 apples. And that goes the same for the multiplicative identity property. 7 times 1 still gets you 7. It's keeping its identity. Now, the additive inverse property, adding a number and its opposite will always result in the sum of 0. So, 4 plus negative 4 equals 0. 7 plus negative 7 equals 0. 25 plus negative 25 is 0. That will always be true. Then we have the multiplicative inverse operation. So you're going to be multiplying its reciprocal. So the reciprocal of a whole number would be that number over under 1. That first number, that whole number would be the denominator. So, for example, 6 times 1 6 would get you to 1, and you do not change the sign to its opposites. And then finally, we have the final two, the distributive property. When you distribute, multiply every number inside the parentheses by the number that is outside. So there will always be an outside number, and you distribute it. 5 times x, it'd be multiplying, as you see here. 5 times x, which is technically, that would be a 1x, so 5 times 1x equals 5x. 5 times -3 would get you -15. And then finally, the zero property of multiplication. Any number multiplied by 0 will result in the product of 0. As you see here, a times 0 would get you to 0. And 3 times 0 would again get you to 0. So you have the original number times 0 equals 0. Any number times 0 will get you 0. Alright, but now let's practice identifying them. So let's do it. Alright, so the first one, 1A. 75 plus 6 equals 6 plus 75. That is the commutative property of addition. Obviously, it's addition because you see the addition sign. And then all it is the numbers flipped, but it's the same two numbers. B is the multiplicative identity. Remember, I said the original number times 1 will keep its identity, so that's the identity property. If the first number times 1 equals the original first number, that is the multiplicative identity. And then over here you have the additive identity because you have h plus nothing gets you to h. It'd be 10 plus 0 still gets you 10, and it still keeps its identity. All right, next question. Letter D. So in this problem, anytime it ends in a 0, that is automatically the zero property of multiplication. Because anything times 0 will get you to 0. E is the commutative property of multiplication because they're the same two numbers. 27 is A, pi is B, so A times B, but you could flip that around to get B times A, which would be pi times 27. So that is, again, the commutative property of multiplication. Then you have the inverse property of multiplication because you flipped the reciprocal and you got 1. Next up, name the property. This is the distributive property. 4 times x, right here. 4 times 8, right there. Next up, you then have the associative property. We went over that on my whiteboard. You have the same 3 numbers, just where the parentheses will not change. And then you have the inverse property of addition because any negative times a positive gets you 0. No, negative plus a positive gets you 0. Alright, so now I want to go over this. Number 6, what is an example of the associative property of multiplication? Well, this isn't, the number 1 isn't, that's the commutative property. Because there's 2 of the same numbers but flipped. That's the commutative property. Number 2 is the distributive property. 6 times 7, 6 times 7, 6 times 3, and 6 times 3. It can't be 4 because that again is a commutative property. This would be A, this would be B, and this would be B, and this would be A. So that can't work. So then out of process of elimination, it is 3. Also because these 3 numbers are the same on each side and just the parentheses are different. Alright, next up. -y plus y equals 0. Remember I said -1,000 plus 1,000 will get you to 0. That is known as the additive inverse, or the inverse property of addition. So, which represents the additive inverse of 1/3. That would be negative 1/3. You add the negative positive, flip that, and you get a negative. Illustrates the identity property. Remember, it keeps its identity. The first number plus 0 gets you the first number. Number 2. Which property is illustrated by the statement 5 times 1/5? Remember the reciprocal. Don't forget the reciprocal is when it flips and the whole number turns into a fraction. That's the inverse property. And then finally, the last one. Consider the following expressions labeled A to D. Let's see. First choice 1. Expression B is equivalent to expression C. Is that true? Yes. It is true. I think. Wait. Yeah, actually. Sorry. I don't know why I didn't know that. Yes, it is equivalent. Expression C is equivalent to expression D, but not to expression A. Yes, because that is the distributive property. So that's why the answer is 2. Alright, actually, I thought I got this wrong, but